Good morning and welcome back to Open School. Today I will be discussing about the nephron, the functional unit of the kidney. Each kidney contains approximately 1 million nephrons. And again, an important point to be remembered is kidney cannot regenerate new nephrons. When the nephrons are lost, it is permanent. It will not get regenerated. At the age of 40 years, the number of nephrons start getting declined. What are the parts of the nephron? The nephron has got a major part is the glomerulus, which is covered in the Bowman's capsule. The Bowman's capsule plus glomerulus forms the renal corpuscle. Then there is a proximal convoluted tubule. Proximal means it is close to the glomerulus. That is why it is called proximal. And it has got convolutions. That is why it is called convoluted. Proximal convoluted tubule. Then there is a looping of the nephron. That is called the loop of Henle. Then the loop of Henle continues as the distal convoluted tubule. And the distal convoluted tubule ends in the collecting duct. And collecting duct finally ends in the papilla into the minor calyces, which form the major calyces, and from there the ureter is formed. So the major parts of the glomerulus of the nephron are the glomerulus, which includes with the Bowman's capsule, the proximal convoluted tubule, loop of Henle, distal convoluted tubule, and collecting duct. We will go a little more detail into the formation of the glomerulus. The glomerulus and tubules together forms the nephron. The glomerulus is formed by the afferent arteriole. The afferent arteriole is a branch of the abdominal aorta that ends as a tuft here, and that is the glomerulus. And the artery which is going out is the efferent arteriole. That is, entering is the afferent arteriole and exiting is the efferent arteriole. A comes before E, so remember A is the artery that is entering. One peculiarity is that it is only place where an arteriole forms a tuft and then again an artery is, that is afferent artery leads on to efferent artery rather than a venule. The nephron consists of the glomerulus and the tubules. And the bulbous end of the nephron is the Bowman's capsule. And the Bowman's space collects the filtrate from the glomerulus. So we have mentioned about the Bowman's space. So it has got a visceral layer, a parietal layer, space between, I have explained Bowman's space, and visceral layer has modified cells. So the visceral layer gets modified, and that is called the podocytes. And the podocytes are encasing the glomerulus. So this is the electron microscopy picture of the glomerulus of a mouse. Here you can see the afferent arteriole forms the glomerulus, and it's a larger view. Here you can see the visceral layer forms food processes as the podocytes over the capillaries. And here you can see that this is the endothelium of the capillary, this is the basement membrane, and here comes the podocytes and the food processes. So the podocytes are modified visceral epithelial cells of the Bowman's capsule. So proximal convoluted tubule, as the name explains, it has got convolutions. It is close to the glomerulus. That is why it is called the PCT. It is the first part of the nephron after the Bowman's capsule. From the filtrate, all the necessary things like glucose and ions. The proximal convoluted tubule is approximately 15 millimeters in length. It is single layered. It has got a convoluted part called the pars convoluta and a straight part called the pars recta. The proximal convoluted tubule is in the cortex, and part of the nephron loops into the medulla, and that is the loop. It reabsorbs. It actively transports salts out of the filtrate. It has got a thin descending limb, a thin ascending and a thick ascending limb. The last part is the distal convoluted tubule, which ends in the collecting duct, and it has got a excretory function, especially acid. The loop of Henle we have discussed. It has got a thin descending limb, a thin ascending limb, and a thick ascending limb. So here this is a thin descending limb, thin ascending limb, and thick ascending limb, which continues as the distal convoluted tubule. And the distal convoluted tubule plays an important role in the excretion of acid and reabsorption of bicarbonate, and it converges into the collecting duct. It is about 5 millimeters long. The collecting duct is around 20 millimeters in length. It has got a part in the cortex, that is a cortical collecting duct, and a part in the medulla, that is the medullary collecting duct. So this part is in the medulla, and the beginning part of the collecting duct is in the cortex. So there is a cortical part and medullary part. It has got two types of cells predominantly. One is the principal cells, second is the intercalated cells, about which we will study in detail in the next sessions. As mentioned, the collecting duct has got two types of cells. One is the principal cells, which are concerned with water reabsorption, which is ADH dependent, and intercalated cells are concerned with acid secretion and bicarbonate transport and secretion. So distal convoluted tubule plays an important role in the excretion of acid and the maintenance of the pH. In this session, we have discussed about the major parts of nephron, that is the Bowman's capsule, the proximal convoluted tubule, loop of Henle, distal convoluted tubule. In the next session, we will be discussing about the glomerulus and how the filtration is occurring and what are the barriers of filtration. Hope this was useful to you. Thank you. Bye.